So for the 3-2 proofs, look at this, please. And I asked you to think about what do you notice in here? What do you notice? Anything you see?
Vertical angles.
Vertical angles in there. What else do you see? You see this mark and this mark? Technically that means X is the midpoint. But what we have here is a little S and a little S. What do we have right here and here? Yep, matching sides. And that was all given to us. The side Rx equals side Sx, Qx equals Tx, and there's no other reason except for the fact that that was given to us. You are allowed to use given in a proof. You are not allowed to use the word prove in a proof because it's your job to prove it. You can't just say that it's already proven. All right, do you remember that from Math 1? We started the beginnings of proofs in Math 1. You remember how you start with the given part?
Yeah.
And then you build from there. So, you're looking at this one over here. Y is angle QXR, this angle right here, equal to angle TXS. What reason could you say for QXR, this one right here, to be equal to TXS? And if you're confused, look over here at these options. You know it, you just be quiet. What reason is there for this angle here to equal this angle here? Vertical angles, that's right. So you're going to say vertical, I knew you knew it. So it's vertical angles theorem. They wrote out the congruent angles. I'm filling in the question mark. I'm filling in the blank with the reason for it. Those make vertical angles. They're across from each other. So I just marked some angles. I'm going to put a little A there. So the last thing you have to do is fill in the blank right here. They said SAS works, and that's true. What we have to fill in is the question marks. What triangle is congruent to what triangle? Now you could make it up yourself by finding the right letters. But in this case, it's already there, so we want to follow the order that they have. That's right. So we're just going to say triangle QXR is congruent to, just do it in their order, TXS. If they don't give you that, if they just say prove that the two triangles are congruent, then you have to be really careful about the order you write them in. That's all it is to a proof, is saying what you need to do and giving a reason for it. So look at the next one down. This one is a 2-column proof. It's not written out with arrows. It's all just written out as a list. Now look what they gave us. They gave us the BD is perpendicular bisector. Perpendicular means right angles. What does bisector mean? Cut down the middle. You have 2 equal halves. So look. They said AD equals CD. They marked these equal, and those are sides. They marked those equal because that's what a bisector does. Definition of perpendicular bisector. They use that. Then they said perpendicular. Perpendicular is used right here. Perpendicular means that these are right angles. So ADB and also CDB are right angles. So, if that's the case, what do I know about all right angles? Which makes them, that's right, they're all 90 degrees, which makes them congruent. All right angles are congruent. So this right angle and this right angle, ADB, is congruent to angle CDB. All right angles are going to equal each other, so you can automatically call them congruent. ADB is congruent to CDB. And you can either say all right angles are congruent, or you can write it out as the right angles theorem. So I want you to go over here and mark the little a. Eventually, we'll be looking at the hypotenuse. It's just going to come later in the chapter. All right, now we get stuck. Something's missing there, but you can see it, just like yesterday and the day before. What part do I need to put in there? The reflexive part. I need to show that the top triangle is similar to the bottom triangle, so I need that reflexive line right there. So put an X on it. And when you do, you're dealing with sides. This side is the same as this side in both triangles. Alright, if you do it, you have to write it. If you're using it in your picture, you have to write it. So over here, we're going to say which segment equals itself. DB. Yep, DB, this segment is equal to itself. For what reason? Reflexive property. Anytime you put an X in your picture, you need to include the reflexive property in your proof somewhere. Now we're down to the last step. They already told us what they want us to do. Triangle BAD, triangle BAD is congruent to triangle BCD. But you have to give the reason now. Look at the picture, and the picture tells you the reason. Look at where your S's are. Look at where the A is. Look at where the S's are. What would that reason be? They used perpendicular bisector already, and it was used right here. So that one they did use, but it was already done. So now, what makes these triangles congruent? These are your choices. Whenever you're trying to show triangles are congruent right now, these are your 4 choices. You have to choose the 3 letters that could work. Say it again. Someone said it already. Let's say yes. All right, that is going to be the case. Every time you're trying to show that triangles are congruent, on the right-hand side, your reason has to be one of those 3 letters until we learn the last one, H-L. But you can see it goes side, then angle, then side. Okay, so proofs aren't hard. All you have to do is find the X where you would put reflexive, or the vertical angles, or SAS, and eventually you'll get a few more acronyms. I turn over to 3-3 proofs. All right, and this time, I'm not going to do all the work. You guys can help. So, start off with what we're given. BD is perpendicular to AC. What does that mean? Perpendicular? Forming what? Like, don't take it away. Right angles. Yep, perpendicular means you have right angles. And what does bisect mean? Cuts them in half. Okay, so that's given. So look at this one. They said definition of perpendicular. That's their reason for it. So if they're using perpendicular, what do you think they're going to create from that? What is perpendicular? What does the definition of perpendicular mean? You just told me. Yes, they make right angles. So look at these 2 right here, and let's write out what the right angles are. They drew one for us. ADB is a right angle. ADB is a right angle. Perpendicular means you have right angles. What's another right angle in this picture? What's another right angle over here? CDB. Good. And angle CDB are right angles. Okay? That comes from the word perpendicular. They gave you the word perpendicular for a reason, so that you could find right angles. Look what they did. They took those right angles and said those are congruent. ADB is congruent to CDB. Why? It's not the exact same thing, though. ADB is congruent to DBC. ADB is congruent to CDB. Why are they equal to each other? Yes, because they're both 90 degrees. So it's the right angles theorem. If you have 2 right angles, they're automatically equal to each other. I'm going to do this next one in a different color so you can see it. But look carefully. What is the middle letter here? B. And what's the middle letter here? So that's where I'm going to draw it. ABD right here is equal to CBD right there. You can't just make that up. There's a word that makes that. Can you find the word that makes this happen? Excellent. We cut an angle in half. So it comes from this word right here that ABC is getting bisected, cut in half. So that's the definition of the angle bisector. When you have a bisector, you can cut it into 2 equal parts. Look at what they said next. What's the key word here and what they said? Reflexive. So we have to use reflexive somewhere in this picture. Where would you use it? BD. Yes, put an X there. And then it's BD is congruent to BD. You haven't given them a chance yet. You've only been doing them for like 1.5 a day. Just wait. Just a couple. And the last one, the reason says ASA. ASA is about triangles being congruent. So on the left-hand side, you have to show which triangles are congruent, and they already told us what to write. Triangle ABD is congruent to triangle CBD because of the angle side angle that we had right here. Angle side angle, angle side angle. Alright, skip the next one because I'm going to have you do that one as a warm-up tomorrow. Turn the page and I'll do one more with you and then we'll skip it and leave the last one for a warm-up tomorrow. But I want to make sure I've gone through enough with you. So this one's going to be for Friday. This one let's do together. You know what? Yeah, we'll go ahead and do this one, but I'm not going to do any talking. This one I want you to look at it and make decisions for me. Start with what's given and look at what's missing. So what should I write here? Mm-hmm. Also, you know what I'm going to do? I'm going to wait and have you think about what the next one is, rather than me just, or having one person just call it out. Look, they made those marks already. PT is congruent to RS, and PTR is congruent to RSP. So I want you to look at number 2, take those angles, mark those in the picture, so you know what angles they're talking about, and then think about a reason for it. Don't call it out. Think about it on your own paper there. And if I were you, I would take angle PQT where the Q is, and I would mark it. Mark the angles that they gave you. What reason did you come up with? Vertical angles, good job. This is angle P or RQS. So what, did you write vertical angles or what did you write? Good. Or you could say the statement, vertical angles are congruent. Alright, stop and examine the third step and see what you can do with it. Okay, what did you end up with from AAS that they gave you right here? What did you end up with? PQT? Congruent to RQS, and that's it. Okay, so you are just looking for the clues that you can fill in the blank.